Hello students, today we will discuss about the metals and non-metals. Now what is metals? Metals are those elements which can lose electrons, easily and form the positive ion. They form the positive ion and they are mostly solids, possesses high density and high melting and boiling point. They have metallic luster and sonorous. Sonorous means producing sound. Good conductor of heat and electricity, and they are malleable and ductile. Malleable change into the sheets and ductile change into the wire. Hardness. Most of the metal are hard. If you try to cut them with a knife, it will not be possible. They are so hard in most of the metals, but some of the metals like sodium and potassium, they are soft and they are the soft metal and can cut with the knife. Malleability, the ability of the metal due to which it can be beaten into sheets, is called malleability. Aluminium, steel, copper, brass, bronze, they are used for the utensils. Brass and bronze sheet are used for the statue, and bronze is used in the making the medals. Aluminium foil is used for packaging the material, and silver foil is used for decorating sweets. Ductility. Ductility is the ability of the metal to drawn into the wires. Ability of the metal to drawn into the wires. Just like copper, aluminium, iron, silver, gold and platinum. They are highly ductile metals. 1 gram of the gold can be drawn into 2 kilometer long wire. 1 gram of the gold can be drawn into 2 kilometer long wire. Sonorous. Sonorous means producing sound when they struck with the hard substance or hard object. Brass and bronze, they are highly sonorous. That's why they are used in making bells and gongs. Electrical conductivity. It is the property due to which electric current can pass through the metal. Due to this property, electric current can pass through the metal. It is due to the presence of free electron, because in the metals free electrons are present or mobile electron are present, and then they can lose the electron easily. For example, copper, gold, aluminium and silver. Copper, gold, aluminium and silver are the good conductor of electricity. Metals are good conductor of the electricity. That is why they are covered with a PVC coating, polyvinyl chloride coating, which is act as the insulator so that we do not feel shock due to the flow of the current. Thermal conductivity, property due to which metal conduct heat. Metal also conduct heat. This is called thermal conductivity. Example, copper, silver, aluminium, gold and iron are the good conductor of heat and electricity. But opposite to this, if we discuss about the non-metals are not hard, they are soft, they are not malleable, they are not ductile, they are not sonorous, and they are not the good conductor of heat and electricity and thermal conductivity. Identify the metals and non-metals on basis of the physical properties. Then what are the exceptions? First, all metals are hard. First, according to the physical properties, metals are hard except sodium, potassium and lithium. They are soft and they can cut even with the knife. Osmium. Osmium is the hardest metal. It is the hardest metal. But lithium is the lightest metal. All metal are solid. All metal are solid except mercury. It is not solid. Cesium, francium, germanium, gallium. They have low melting solids. They are low melting solids. Gallium become liquid if kept on the palm. Gallium is have less melting point and it will be changed into the liquid if kept on the palm. But gallium has high boiling point. Gallium have high boiling points which make it useful for high temperature for the thermometer, high temperature thermometer. Iodine is a non-metal. Iodine is a non-metal, but it has metallic luster like the metals. Metal have luster, but iodine is a non-metal and it is lustrous. Diamond. Diamond is the non-metal, allotropic form of the carbon. It is also highly lustrous. Non-metal. Non-metal have low melting and boiling point. Non-metal have low melting and boiling point. But diamond, boron, silicon and graphite, all they have high melting and boiling point. Metals have high melting and boiling point. Non-metal have low melting and boiling point, but metals have high melting and boiling point. Tin has the highest melting point and it is used in the bulb and its melting point is 3300 degree Celsius, whereas sodium and potassium have low melting and boiling point. Sodium and potassium have low melting and boiling point. Non-metals are bad conductor of heat. Bad conductor of heat and electricity. But graphite is a non-metal and it is the good conductor of heat and electricity. Metals have high density. For example, copper, chromium, silver, gold, platinum, osmium, all they have high density. But metals like sodium, potassium and lithium have density less than 1 gram centimeter cube inverse. Diamond is a non-metal but it has a high density. Diamond is a non-metal, it has high density. Generally metal have 1 to 3 valence electron. 1 to 3 valence electron in the outermost shell, but hydrogen has 1 valence electron. Hydrogen has 1 valence electron, but it is a non-metal. Helium has 2 valence electron, but still it is a non-metal. Metals usually have a bright metallic luster and are silvery white in appearance. But gold, it is a metal and it is yellow in color, and copper is a metal and it is reddish brown in color. Non-metals. Non-metals generally do not form alloys, but carbon is alloyed with the iron to form the steel utensils. Carbon is alloyed with the iron to form the steel. Thus, metals and non-metals cannot be classified on the basis of the physical properties only. We cannot classify them. There are a lot of exceptions in metals and non-metals. That's why we cannot classify on the basis of physical properties. Only chemical properties are more suitable to classify them. Chemical properties of the metals. When metal burn in air or oxygen, then they produced the metal oxides. Metal oxide is produced when react with the air. Metal plus oxygen, they form the metal oxide or oxides of metal are formed. 2Cu plus O2 equal to 2CuO. Metal oxides react with the acid. What happens when the metal oxide react with acid? Then salt and water is formed. Salt and water is formed when metal oxide react with the acid. Al2O3 plus 6HCl is equal to 2AlCl3 plus 3H2O. Metal oxides are basic in nature, but some metal oxides such as aluminium oxides, zinc oxides, they are both acidic as well as basic behavior. They are showing acidic as well as basic behavior. Amphoteric oxides, metal oxides which react with both acid as well as base to produce the salt and water are known as the amphoteric oxides. Example, aluminium oxides and zinc oxides. When metal oxides react with water, they form the alkalis. When the metal oxide react with water, they form the alkalis. Na2O plus H2O equal to 2NaOH. When metal react with the water, then metal oxides and hydrogen gas is produced. Metal plus water equal to metal oxides plus hydrogen gas. 2K plus 2H2O equal to 2KOH plus H2 gas is released, and it is very vigorously or very violently released, and it is highly exothermic reaction, and it can get fire very speedily. Potassium, sodium react with the cold water. They are so reactive metal. They will react with the cold water very violently, and hydrogen gas immediately catches fire. Calcium plus water. Calcium is not so reactive just like potassium and sodium. It is less reactive than sodium and potassium and less violently it reacts. Calcium starts floating on the surface and form the bubbles of the hydrogen gas and stick to the surface of the metal. That's why it will not catch fire. Magnesium. Magnesium not react with the cold water, but it react with the hot water, and it is less violent, and bubbles of hydrogen gas stick on the surface. Aluminium, iron, zinc, they are not react with the hot water and cold water. They only react with the steam. But lead, copper, silver, gold, they are non-reactive metal or very less reactive metal. They do not show any reaction with the water. Now, when metal react with the acid, metal plus dilute acid, then it form the salt plus hydrogen gas. Hydrogen gas is not evolved when a metal react with the nitric acid. When metal react with dilute acid, every metal release the hydrogen gas, but with the dilute acid, but only the nitric acid, hydrogen gas is not evolved with the nitric acid because HNO3 is a strong oxidizing agent. It is a strong oxidizing agent and no hydrogen gas is released. It oxidizes the H2 produced to water. It oxidizes the hydrogen and mix with the oxygen and produce the water and itself get reduced. When metal react with solution of the other metal salts, then displacement reaction take place. The highly reactive metal displaces the less reactive metal of the solution, and then displacement takes place and salt solution of A is formed and metal B released from here. How do metals and non-metal react? Metals are those elements which can lose electron easily. They can lose electron easily. Reactivity of the metal depend upon how easily metal can lose electron and form positively charged ion. Metal have 1 to 3 electrons, whereas non-metals have 4 to 8 electrons in their outermost shell. Reason for metals for losing electrons. In the electronic configuration, noble gas has 8 electrons in the outermost shell and they are quite stable. It means all the metal will try to lose electron to attain the noble gas configuration. Non-metal can gain electron to form the negative ion. so as to acquire the stable noble gas configuration. We can take the example of sodium. Sodium atomic number is 11, electronic configuration is 281. Chlorine is the non-metal and its atomic number is 17 and electronic configuration is 287. Sodium will lose one electron and attain the noble gas configuration or complete its octet. Similarly, chlorine gain one electron and attain the noble gas configuration. Sodium lose one electron and chlorine gain one electron, and this transfer of the electron is called ionic bond, and sodium chloride is formed. Ionic bond, the bond which is formed by the loss and gain of the electron is called ionic bond or electrovalent bond. Now, what are the properties of the ionic compound? They are solid, hard, brittle. They have closed pack structure, high melting and boiling point, conduct electricity in the molten state only, not in the solid state, because in the molten state free electrons are there. They are soluble in water because they break down into the ion, but insoluble in the organic solvent because they do not form ion in the organic solvent. Occurrence of metals. How the metal occur from the earth crust or seawater. Main sources of the metal is earth crust, and some metals are also present in the seawater in the form of their salts. Now, what is mineral? Mineral is the element or compound which occur naturally in the earth crust is known as minerals. They are occur naturally on earth crust. Ores. They are the minerals from which metals are extracted profitably. These are the minerals from which metals are extracted profitably. These minerals are called ores. Metallurgy. All the process involved in the extractions of the metal from their ore and refining them for use is called metallurgy. Process of metallurgy is started from the concentration of the ore, and it can be separated by the metal of high reactivity, metal of medium reactivity, and metal of low reactivity. Metal of high reactivity is separated by the electrolysis of the molten ore. In the electrolysis process, when NaCl is taken, electrolysis is done with the help of electricity. It will break down into the sodium ion and chlorine ion. At the cathode, sodium ion form the sodium, and at the anode, this reaction takes place. Chlorine ion form the chlorine, and then after the electrolysis, pure metal will obtain. Metal of medium reactivity. It is done by the two processes, calcination and roasting. Calcination is done in the absence of air. Roasting is done in the presence of air. Calcination is done for the carbonate ore. Roasting is done for the sulfide ore. And after calcination and roasting, metal oxides are obtained, and these metal oxides are reduced. After the reduction of the metal, purification of metal is done. Metal of low reactivity series. Here sulfides ore are taken. By the process of roasting, we get the pure metal, and roasting is done in the presence of air. And after this obtaining the metal, refining is done. Enrichment of ore or ore dressing. Ore dressing. Process of removing unwanted substance from the ore. It is usually done by the hydraulic washing, magnetic separation or froth flotation process. Hydraulic washing. In this process, crushed ore is washed with the stream of the water, lighter gangue particle washed away, and heavier mineral particles settle down and obtained. Froth flotation process. It is used for the sulfide ores. It is used for the sulfide ores. Powdered ore is mixed with the water and suitable oil and then agitated. After agitation, oil froth is formed and which contain the mineral and gangue particles settle down. Third is magnetic separation. Magnetic separation is done for the magnetic ore. Magnetic ore is separated by this process, magnetic separation. Here are the two magnets, so two rollers are here and the one belt over rolling over it, and when we put the powdered ore on this belt and when this belt move, then due to the effect of the magnetic properties, this magnetic material fall down here and the gangue particle fall away. Thermite process or aluminothermy. This is done for the welding of the railway tracks, in which molten metal oxides are treated with the aluminium powder. Molten metal oxide. Metal oxide is treated with the aluminium powder and used for the welding of the railway tracks or cracked machine part. It is highly exothermic reaction. Then this metal oxide is treated with the aluminium powder and then form the aluminium oxide and iron, and large amount of heat is evolved. Refining. Refining process of converting impure metal into the pure metal. First is electrolytic refining. It is used for the purification of metals like zinc, copper, aluminium, chromium, tin, lead, nickel, gold. Impure metal is made anode. Impure metal is used as an anode and strip of the pure metal is used as cathode. On passing electric current, cation move towards the cathode. Cation move towards the cathode and gain electron, and pure metal get deposited on the cathode, while impurities called the anode mud and settle at the down. Certain valuable metals which can be recovered from this anode mud. What is corrosion? Corrosion, in which metal react with the substance present in the atmosphere to form the surface compound. Silver metal turn black, copper form greenish layer, iron form reddish brown coating that is called rust, and its formula is Fe2O3xH2O. How can we prevent the corrosion? It can be prevented by oiling, by greasing, by painting, by galvanization, or by electroplating. Galvanization. It is the process of coating iron article with zinc, which is more reactive than the iron. It is called galvanization. Alloys. It is the homogeneous mixture of two or more metal, or one may be metal and one may be non-metal. Amalgam. Amalgam, metal alloyed with the mercury. If the metal alloyed with the mercury, then called the amalgam. Now, what is the purpose of making alloy? Do not corrode it. If it is made from the alloy, then it will not be corroded. It will be hard, it will be strong and less conductance. What are metalloid? Metalloid are those which have characteristics of both metal and non-metal. And example of metalloid are germanium, silicon, tellurium and antimony. Thank you.